Hi everyone, welcome to my channel. Today I'm going to discuss the topic parts and functions of control system for the subject Auto 1 or Automation 1. So we have here STCW function, electrical, electronics, and control engineering at the operational level. Table of competence A-3/1, function to chapter 1. Operate electrical, electronic, and control systems under QOP 1.1, theoretical knowledge of automatic control engineering, QOP 1.3, basic configuration and operation principles of control equipment. So we have here various automatic control methodologies and characteristics, proportional, integral, derivative, or PID, control characteristics and associated systems, devices, or process control. So we have the course outcome, differentiate basic construction principles in automation regarding various measuring instrument and automation devices used in those ships. So we have learning objective. So at the end of this lesson, the learners shall be able to describe what devices, equipment, construct, control system, and their roles and function. So we have here fundamentals of automatic control. Learning objective number one, define an automatic control and states its purpose and some applications. Learning objectives number two, describe what devices, equipment, construct, control, systems, and their role and functions. We also discuss the main function and some application of control systems, basic features and configurations of control systems, control system analysis, and design objectives. Control system design process and benefit from studying control system. So after discussion, we conduct a class oral station. Then during the discussion, and give quiz number one. So we have also laboratory exercise one, your lab manual, parts and functions of control system. So I send this one in your binocle. So what is automatic control? So it is the application of control theory for regulation of process without direct human intervention. So this closed loop control is an application of negative feedback system. So meaning without human intervention. So for example, the machine is in operation or running. There is no need to control by the operator because it is controlled by the automatic control, which is called closed loop control system or feedback system. So there is no need for the human to control. So that is uh, uh, the meaning of without direct human intervention. So in this lesson, we'll explore the importance of studying marine automation, the basic components and concepts of open loop and control rope control system, also the basic elements of control rope. So we have the video uh, this, but I cannot open this link. So we'll continue. Automation changes the world we are living in. It affects almost every aspect of our life, the knowledge, in the workplace, especially in the industry. We are surrounded with machines and equipment that makes our works more effectively and efficiently. In maritime shipping industry, automated ships are being developed, which makes the lives of seafarers easier. However, people required to operate these ships are becoming fewer and require more advanced skills. In order not to be left behind by this technological advancements, we have to equip our future seafarers with the basic concepts, skills, marine automation, and automation. A control system can be classified as open or closed loop. Open loop system, also referred as a non-feedback system, is a control system in which the output has no influence or effect on the control action of the input signal. So the block diagram is shown in figure 1. The other hand closed loop control system is set to a mechanical or electronic devices that automatically regulates a process variable to a desired state or set point without human interaction. The block diagram of basic elements is shown in figure 2 here. So we will discuss this diagram, both open loop and closed loop system. So in an open loop system, we have a manipulated variable, we have a control element, we have the input, process, disturbance, and output. So what is manipulated variable? Here, so manipulated variable is the input variable parameter to a process that is varied by control signal from the processor to an actuator. So remember the keyword, it is the input variable or parameter. So you put the input in here or the set point, and then that input is being controlled by your control element. So by the way, what is control element? So it is the device that controls the incoming material, the process. So the input, the manipulated variable here, the parameter is being set to the controller and it's being detected by the control element. So there is an input, it's being processed to have the result here as an output. But there is also a disturbance here in the process. But as you can see here, there is no feedback. So this uh, this open loop system is a non-feedback system. Non-feedback system. So you have to remember that keyword. Open loop system. Open loop control system is a non-feedback system because you cannot see any feedback here from the output going to the uh, control element. So this is open loop. Next, So next, we have here the closed loop control system. So we have also here manipulated variable, control element, input, process, and the output. So we have this system in the open loop. We have also here. But the only thing different here is there is a feedback from the output. So we discuss this one by one. So manipulated variable. Here, uh, we have the feedback. So feedback loop is the signal path from the output back to the input. So here, the signal from here is sending back a feedback signal going to the control element here. And then the control element will have the input again to process to maintain this, control the output. So in other words, in the closed loop control system, there is a feedback signal going to the control element. So here, there is also an error signal going to the controller. So whatever the set point here, let's say for example, a set point. So what is set point? Set point is a desired value of the output parameter or variable being monitored by a sensor. So any deviation from this value will generate an error signal. So here, so there is a set point here in the controller, and then this set point uh, is a desired value of the output here. So any deviation, or let's say uh, here uh, in the system of jacket cooling water of the main engine, output or the outlet cooling water temperature of the main engine is usually 80 uh, degrees Celsius, especially on modern ship, because of the metal is more durable nowadays. They improve the quality. So higher setting of the which is 80, the outlet temperature of the cooling water temperature of the engine. So supposedly here is the outlet of the cooling water of the main engine is 80 degrees Celsius. So any deviation, let's say it is already the measured element is already 85, 91, 90, 95. That is already alarm. So any deviation is being measured here from in the sensor is being sent to the comparator, and it is also measured here the error. There is an error signal. So compare to the set point of 80. Let's say already 95 here. So there uh, should be an alarm on that measured value. So that is already alarm. So that is being monitored by the controller when comparing to the set point and uh, measured value here by the use of your measuring element, which is the sensor. So uh, that also controller sends signal to the control element, and then it process again, and this should be maintain here the output uh, of 80 degrees Celsius, which is your set point of the desired output. So uh, this is a closed loop control system. So we have also here the control element, control variable. This is controlled by the control element, measuring element. So is the device controls the incoming material to process. So here, element. So here in a control measuring element, there is an error detection. So it is the determination of the difference between the amplitude of the measured variable and the desired reference point. So whatever uh, the measuring element uh, read here, it will send to the comparator, then to be monitored by here, the arrow signal, and send back to the controller in, to compare to the set point and send back the signal to the measuring element, the control element, give again the input, and it is processed, and when the input is processed, there is an output here, the result, which is the same with your set point. So that is the explanation of the closed loop system. So let us proceed. Here we have the definition of terms here uh, used in the automation system process. So I don't need to read all of this. So process, automation, measurement, sensor, error detection, controller, control element, connection signal, actuators, error signal, feedback loop, manipulated variable, set point, transducers, and transmitters. So you just read this one and understand how these uh, terms apply to the system, control system. So next, so there's a video basic of marine control engineering by Engineer Louis Vera. So I already gave you the link in the Binacle. So I hope you watch this one already. And because this is a discussion, a part of the discussion of our topic for week one. So next, we have here some of the questionnaires that might be uh, that you might be encountered during your quizzes, examination, and uh, oral recitation. So we will do the review in these questionnaires. So here we have manipulated variable is not the input variable or parameter to process that is varied by control signal from the processor to an actuator. So what do you think? What do you think in this statement? Is this true or false? The answer is false because manipulated variable is the input variable or parameter to process by a processor and going to the actuator. So the answer is false. Next, we have here error signal. So is the difference between the set point and the amplitude of the measured variable. So here in the diagram, as I showed you earlier, so error signal is the difference between here, set point to the variable amplitude. So that is error signal here. Next, so actuators are not devices to control an input variable in response to a signal from a controller. So the answer is false because actuators are the devices that control an input variable in response to the signal from the controller. So here, so the location of your actuator is somewhere between the process between the input and the output. So here is the actuator here. So in simple words, actuator is the motor to open the motor attached or the diaphragm or whatever the uh, system to open the valve, to open or close the valve, or to rotate the gear, or let's say this motor. So that is called actuator. So the answer here is false. Next, correction signal is the signal that controls power, the actuator to set the level of the input variable. So the answer here is true because correction signal is the signal that controls power, actuator to set the level of the input variable. So here, so correction signal. So it's not shown here in this diagram because this is basic diagram. But whatever here being measured here in the measuring elements which is your sensor will be sent back to the controller applied with the error signal comparing to the set point and sent back to the control element. So that is that is correction signal. So we will continue. Next, error detection is the determination of the difference between the amplitude of the measured variable and the desired set reference point. So error detection. So difference between amplitude and measured value. So here. So so amplitude and measured variable. Error detection. Here, so error detection here is the difference between the uh, amplitude variable and the control variable. Error. So next, error detection. So the answer here is true. Here is true. So a sensor is not a device that can convert a physical parameter repeatedly and reliably into a form that can be used or understood. So the answer is false because a sensor is a device that can convert a physical parameter repeatedly. So here, sensor here. So here, measuring element is here is the sensor. So this sensor sends signals to the element, sends signals to the controller. Next, measurement is the determination of the physical amplitude parameter of a material. The measurement value must be consistent and repeatable. The answer is true because it is the measurement of the parameter and the measurement value. So here, measurement value is being measured here by the sensor or the measuring element. Send signal to the controller and to the control element. So the answer here is true. Next, automation is a system where most of the production process, movement and inspection of materials are performed automatically by specialized system equipment without operator intervention or human intervention. The answer is true because, in other words, automation is the root word here is automatic. So automation does not require human intervention when the machine is already running because it is controlled by a controller which is called the feedback system or uh, closed loop control system here. Here, this one. So the answer is true. Next, process is a sequence of events designed to control the flow of materials through a number of steps in a plant to produce the final utilitarian, utilitarian product or material process. So remember the keyword is a sequence of events designed to flow of materials. So here, this is the process. So as you can see here, there is a flow of material here. So from the manipulated variable, which is your input, uh, being sent to the control element, and then there's an input again to process, and then pass to the disturbance, and then uh, after the process in the input, there is a result or the output. So it is a sequence of events. Same here, the input is being processed, and there's an output. Output is being measured by measuring element or sensor, sent back to the controller, signal, error signal, comparing to the set point, and it is also sent back to the control system, control element, and then it's an input again, then process, and then output. So it is a sequence of events. Control system design, so the answer here is true. There. Control system design is the process of defining the components, modules, interfaces, and data for a system to satisfy specified requirements. Requirements. So the answer is true because here, if you can see, there is components, modules, interfaces, the data in the system that is already control. That is control systems. Control system. So this is control system. As you can see, the open loop control system and the closed loop control system. So the answer here is true. Next, automatic control is the application of control theory or regulation of processes without direct human intervention. Closed loop control is an application of negative feedback system. So the answer is true. So in this automatic control system, there is no human intervention or when the machinery is in operation or running, then the operator uh, only monitor the condition, but visual condition, but the machine is running with the automatic control system uh, because of the feedback system. So the answer is next. Blank is the desired value or the output parameter or variable being monitored by a sensor. In addition, from this value will generate an error signal. So that is called set point. Set point here. Set point. So this set point, let's say, as an example, uh, the jacket cooling of the main engine, outlet temperature, cooling water temperature is 80 degrees Celsius. 80 degrees Celsius. So it is being set in the controller, and that set point or desired variable is being measured through the output by a measuring element, which is the sensor, and the signal is being sent back to the control element, sent back to the controller, and applying the error signal, then comparing to the set point and send back again to the control element. Then there's an input process, is input, and there is an output which is equal to the set point. So uh, here the answer is uh, here is set point. So next, blank is the signal path from the output back to the input. which is used to correct any deviation between the output level and the set level. The answer is feedback loop because here uh, the output signal output back to the input here. So the feedback signal. So the signal from the output is being sent back by a feedback signal to the input. So the answer here is here is feedback loop. So next blank is the device that controls the incoming material process. It is control element. Controls the incoming material to process. So control element here. Control element. So next blank is microprocessor based system that can determine the next step to be taken as a sequential process or evaluate the error signal in continuous process to determine what action is to be taken. So that is controller. So it is a microprocessor based system. So here it is a controller. Here, microprocessor based system. Next, identify the system shown in the diagram. So here, so the answer here is closed loop system, and here is open loop system. So in your questionnaires, you have to view this full image, and you have to identify which system, which control system uh, here inside this image. So here, you have to familiarize this one, this open loop system or non-feedback system, and this is closed loop control system, which is feedback system. So you have to familiarize that control system diagram. So the answer here is open loop, and here is closed loop. So next, control system analysis and design objectives are robust stability, input and output, sorbance reduction, good transient response, noise reduction. So in different system, uh, but the same objectives of the control system analysis. So the answer is that one. Robust stability in both and output, robust reduction, transient response, noise reduction. So next, the basic features and application of control systems are open loop and closed loop system. The main function and some application of control system. So manage, commands, directs, or regulates the behavior of other devices, the plants, system using control loops. So this one this one. So open loop control system and closed loop control system. So this is the end of the discussion. I hope you learn something from the discussion so that you can answer in your quizzes, oral station and examination. Please click like, write a comment below. Don't forget to subscribe. Click subscribe. Click notification button. Thank you for watching. See you on my next video discussion.